Good evening, everyone. I guess you guys are preparing well for the GATE examination. So, in today's session, we'll be seeing some most important numerical answers, some important MSQs. So, from machine design. Okay. So, as you know that the most important topics from machine design are static loading and will be from this topic itself. Okay, I guess you have gone through this topic carefully. So here in this session, let's see some most important details. Let's see this question. A solid shaft of diameter 100 mm having yield strength 260 megapascal carries an axial load of, see, for you to understand or for you to see this question clearly, let me move out of the screen. So a bending moment of 5 kilonewton meter and a twisting moment of 8 kilonewton meter at the ends as shown in the figure. So this is the figure, so in which we can notice that there is axial load P as well as there is bending moment M, along with that we have twisting moment T. The ratio of factor of safety according to von Mises and Tresca theory is, okay, we need to identify what is the ratio of factor of safety according to von Mises and Tresca. So let's see this. Okay, we know that the factor of safety according to von Mises is represented by NV, and the factor of safety according to Tresca theory be represented by NT. Okay, we need to find this ratio. To find this ratio, let me make use of von Mises equation and Tresca equation. So as we can notice that this is a combined loading condition. So if I consider the state of stress for this case, let's consider the state of stress. The state of stress is like this. The particle is subjected to normal stress as well as shear stress. There is normal stress. This normal stress is due to axial load as well as bending moment, whose magnitude is generally represented as sigma x. We need to find the magnitude sigma x here, as well as it is also subjected to shear stress. This is tau x y. Now here if I consider the relation according to von Mises, we get this relation. We get the relation to be like this. What is the equation that we have according to von Mises? Under root sigma x square plus 3 times tau xy square under root. This is equal to SYT divided by factor of safety NV. Similarly, what is the equation that we have according to Tresca? It is tau max is equal to SYS divided by factor of safety NT. For this specific case, we know that tau max is nothing but equal to radius. Okay, we need to identify the radius of this given situation, given loading condition. That's it. Okay, so from here, if I substitute the values, what do I get? NV by NT is equal to, okay, we can send NV and NT, or, okay, let me write like this, 1 divided by sigma x square plus 3 times tau xy square, okay, and here we have SYT into tau max, okay, into SYS. This is SYS according to Tresca, and we know that SYS according to Tresca is nothing but equal to SYT by, is that SYT by 2? Okay, so here this can be written as 2 times radius divided by under root sigma x square plus 3 times tau xy square. Okay, now we need to find the radius sigma x and tau xy for the given loading condition. How to identify? So we know that sigma x is nothing but equal to, or let's assume sigma axial here, which is 5 kilonewton 5 into 10 cube divided by area, pi by 4 into d square. What is the diameter given? Diameter is given as 100 square. Okay, if you notice here, so this is 10 power 4 and this is 10 power 3. Here this is 10 times. So 4, when it goes to the top, that becomes 25. 4s are 20. This is 20 divided by pi, or 20 divided by pi into 10. So here this becomes 0 and this cancels out. This becomes equal to 2 by pi. Okay, is this the magnitude of axial load given? Oh, we can notice that the axial load is very small, 2 kilonewtons and 100 mm. So here this comes out as 2 by pi. Okay, so what about bending stress? Sigma b comes out as 32 into m. M value is 5 into 10 power 6. Why is that 10 power 6? Kilonewton meter. So we are writing this as kilo is 10 power 3 and meter to mm is 10 power 3. So kilonewton meter. So we are converting that to Newton mm divided by pi times 100. So 100 cube and this one cancels out. And here what is 32 into 5? This is 160 divided by pi. Okay, what is the unit here? Newton per mm square. Okay, similarly, what is the shear stress that we have tau? It is 16T. What is T value here? What is T value? 8 kilonewtons. 8 into 10 power 6 divided by pi d cube, which is 100 cube. So these two cancels out. This comes out as 128 divided by pi Newton per mm square. We know that sigma x value is the summation of these two. Okay, as it is a summation of sigma a and sigma b. Here, as the value of axial is very small, we can neglect the axial value and we can consider sigma x value to be directly equal to sigma b. If I substitute the same, what is the equation for radius? The equation for radius is under root sigma x minus sigma y by 2 whole square plus tau xy square, 2 into under root sigma x value is 160 by pi sigma x minus sigma y by 2 whole square plus tau xy, which is 128 divided by pi whole square. Okay, whole divided by sigma x is 160 by pi whole square plus 3 times 128 by pi whole square. This is in root. Now we can notice that there is pi in both numerator as well as denominator. Okay, so this pi can be cancelled out. We can remove this pi and let's see what is the answer that we are going to get. Okay, so if you solve this, it is solve this answer, it is 80 square plus it is 160 square plus 3 times 128 square. This is in root. It comes out as 1.104. So somewhere this value comes out as 1.104. So I guess you got the same answer, the similar kind of answer. Have you got this answer? Please let me know whether you got the same answer or not. Whether you got the same answer or not. I guess this answer is very much clear. See, this way we can solve this question in very minimal steps. Okay, you need to understand this. Moving to the next one, let's see the next equation here. Observe this carefully. A solid circular shaft of 1.6 meter length is subjected to a load varying between 2 kilonewton and 6 kilonewton at its midspan. The shaft yield strength and corrected endurance strength are 240 megapascal and 160 megapascal respectively. If the factor of safety according to Soderberg is 2.5, then the suitable diameter of the shaft is. He is asking us to identify the suitable diameter of the shaft. How to find this? He says that there is a solid circular shaft of 1.6 meter length. It is subjected to a load which is varying between 2 kilonewton and 6 kilonewton at its midspan. So here it says that, okay, let's assume that this is the simply supported beam which is given, as this is the simply supported beam. Okay, so there is a point load which is varying at its exactly at the midspan. Let's assume that this is the load which is acting here. Okay, let this be the P. So here is subjected to load varying. So actually this is represented as simply supported beam. Okay, it has to be mentioned in the question as simply supported beam. Do understand this. Okay. Okay. So here the value of P is varying from 2 kilonewton to this value is varying from 2 kilonewton to 6 kilonewton. Wow. Respectively. See, as it is varying, we know that it is generally considered as simply supported beam subjected to point load at its center. Now this point load is changing from 2 kilonewton to 6 kilonewton. Now we need to design this. So based on Soderberg theory. Okay, let's see how to solve this question. So here first we need to identify what is the critical section. What is the critical section here? The critical section is the section of loading. Just below the load, so we have maximum load. Okay, as this is a section which is critical, we need to identify what is the maximum moment. So we can say that here the section of loading is critical. The section of loading is critical. As the section of loading is critical, we need to identify the value of M at that critical section. We know that as this is simply supported beam, its value is PL by 4. What is the value of L here? P into 1600 divided by 4. This is 4 ones are, 4 ones are, 4 fours are. So this is nothing but equal to 400 P. Okay. So we need to identify this unit. Okay, let me assume this to be in Newton mm. If you substitute the value of P, or if I consider the value of P in kilonewtons, I can write this as kilonewtons mm. Okay, if P is in kilonewton, then the unit will be kilonewton mm. Now we need to identify, as we have identified what is the maximum possible value of moment. Now we need to identify the mean value as well as the amplitude value. So what is the mean value of moment? Mean value of moment is nothing but equal to, okay, 400 into, what is the mean value of load here? It is 4000. Is that 4000 newtons? Yes. So this is nothing but equal to 16 into 10 power 5 Newton mm. Similarly, what is amplitude? Amplitude is nothing but 400 into 2000. Okay, which means, so 4 2s are 8. I can say that this is 8 into 10 power 5 Newton. Okay, 16 into 10 power 5 Newton mm, and amplitude here is 8 into 10 power 5 Newton mm. Now we need to identify what is the equation for stress. Can you please say me what is the equation for stress here? Sigma is equal to, as this is circular cross section, we can notice that it is 32 m divided by pi dq. Okay, what is the diameter that is given, which we need to identify. So considering Soderberg, I am taking 32 by pi d cube as common into what is left over here. So mean value of load is, let me consider this to be 16, or okay, 16 divided by, what is the value of yield stress? Yield strength of the material is given as 240. This is 240 plus, okay, amplitude value is 8 divided by 160 into 10 power 5 is equal to, okay, so we have considered the value of factor of safety, right? What is the factor of safety given? It is 2.5. 1 divided by 2.5. So calculate this value, substitute the values, you'll get the answer. So here it is 8 ones are, and this is 20. Okay, what about here? So it is 8 twos are, 8 threes are. Okay, this is 30. Now, what is the denominator that we are getting? So do this simple calculation, get the answer. So it is the value of D comes out as somewhere here, the value of D comes out as 66.72 mm. So if you notice the options here, so what is he asking? Round this to the nearest integer. Okay, if I need to round this to the nearest integer, I need to round this to 67 mm. The answer to this question comes out as, we need to fill the answer as 67 mm. Okay, as we are rounding this to the next integer. Okay, moving to the next equation, let's see this question. Observe this. This is one of the most important questions. A shaft pulley assembly is supported and loaded as shown in the figure. If the yield strength of the material is 300 megapascal, considering the factor of safety of 2, the suitable diameter of the shaft is. Here we need to identify what is the diameter of this shaft. Here you can notice that, okay, so one is driving pulley, other one is driven pulley. So here you can notice that maximum tension here is present on the front side, whereas on the other case maximum tension is present on the back side. Okay, now here in this case, as we can easily notice, if I need to draw the free body diagram for this case, let me draw the free body diagram. The free body diagram comes out to be like this. Okay, here we have support A and this is B. Okay, and here we have reactions. So this is A and B over. So at C, how much is the load that we have? So it is 6 plus 2. What is the magnitude of 6 plus 2? It is 8 kilonewton, which is acting in downward direction here. This is 8 kilonewton acting in downward direction. Similarly here, it is 8 kilonewton acting in downward direction. Okay, and here this is simply supported beam which is subjected to load in this way. And here you can notice that it is almost symmetric. So from the left side pulley to the left side support it is 0.5. From the right side pulley to the right side support it is 0.5, and the distance between these two is 1 meter. And here if I need to identify the reactions here, this is 8 kilonewtons and this is also 8 kilonewtons due to symmetry. Okay. Now, what is the answer that we need to find here? If you notice, here in between these two, and here if I draw the bending moment diagram for this case, the bending moment diagram, so the bending moment will remain constant in this region. So in this region, the bending moment will remain constant. Okay, as that is constant, what is the magnitude of bending moment here within this region? So in the complete region of C and D, CD, the bending moment that we have, M is equal to, so the reaction which is 8 kilonewton, 8000 newtons, into what is the distance between D and B? It is 0.5 meter, which is 500 mm. Okay, so we can write this as 8 5s of 40 into 10 power 5 Newton mm. Similarly, if you notice, there is a torque which is getting transmitted here through this arrangement. How much is the torque here? Now we can notice that the torque here is equal to 6 minus 2. So it is 4 kilonewtons, 4000 into, it is acting at a radius of 120. Okay, so what is this value? 12 fours are 48. I can write it as 4.8 or 48 into 10 power 4 Newton mm, or here we can write this as 400 into 10 power 4 Newton mm. Okay, now here what is the theory that he is asking us to consider? The suitable diameter of the shaft is. See, did he specify any theory to be used? When he is not specifying any theory, we tend to consider maximum shear stress theory for safety. Considering maximum shear stress theory, I can say that it is tau maximum to be lesser than or equal to SYS divided by factor of safety. Okay. So did he give factor of safety? Considering a factor of safety of 2 is what is mentioned here, nothing is specified. Yield strength of the material is also given. Okay. Now here we know that tau max is nothing but equal to 16 by pi d cube into under root m square plus t square. Okay, as nothing is specified, we are considering. Okay, again let's see whether it is given as maximum principal stress theory or shear stress theory, or nothing is specified. So that's the reason why we are going with maximum shear stress theory for the design. Okay, is lesser than or equal to SYS divided by factor of safety. Okay, now what is 16? What is here we need to identify the diameter, right? 16 by pi d cube into under root m square. What is m here? M here is 400 square plus the value of t is 48 square into 10 power 4 is lesser than or equal to, what is SYS here? We know that SYS is nothing but SYT by 2, whose value is nothing but 150, and this is divided by factor of safety which is considered as 2. Okay, so let's solve this case. Let's see this. Let's find the answer to this question. It is 400 square plus 48 square, which is in root into 16 divided by pi into 10 power 4 divided by 75. Okay, so this is the value of d cube. It comes out as the value of d again in this case is coming out closer to 64.91 mm. 64.91 mm. So is he asking us to round this to the nearest integer? No, as he is not asking. Now we'll be directly substituting that as 64.9 mm here. Okay, as he didn't say to how many decimal places it has to be rounded, we tend to substitute it as 64.91. Okay, I guess this answer is very much clear. See, these are not difficult questions, so you need to know the logic to solve these questions. That's it. Let's see one most interesting question here. A flange coupling is used to connect two concentric shafts using 6 bolts. So with a bolt circle of radius r is equal to 800 mm. You can notice that. So this is how the arrangement is looking like. Okay, in this arrangement, all these bolts are present along a circle. This circle is having a radius of 80 mm as shown in the figure. The shaft transmits a torque of 10 kilonewton meter. If the yield strength of the bolt material is 200 megapascal, then the suitable shank diameter of the bolt is. So here we know that the shank here is in shear. We know that. So for whenever the bolt is subjected to shear, we tend to consider the shank to be in the section of shearing. Considering shank to be present in the section of shearing, so here round to the nearest integer, okay, this is overlapped here, the diagram got overlapped. So here he is asking us to the rounding to the nearest integer. Okay, let's see the answer to this. How much is the torque which is applied? The torque which is applied is 10 kilonewton meter. This magnitude is 10 kilonewton meter. Okay. Now we need to identify what? The shank diameter. If you notice, observe here carefully. If this is action, okay, obviously some resistance is coming on the bolt. This is the reaction which is exerted by the bolt on the member. See here, as you are trying to rotate, okay, the bolt here is exerting some load on it, so that the reaction is coming in the backward direction. If this is action, this is the reaction that we are getting on the plate itself, okay, on the flange itself. This is action on the flange, the same is the reaction on the flange. This is at one location, okay, or if I remove this, I can show the effect on the bolt. The effect on the bolt is in this direction, is in tangential direction, is in tangential direction, is in tangential direction. Okay, this is the effect of the torque on each bolt. As all the bolts are identical in nature, okay, now I can say that, let's assume that P be the load which is acting on each bolt, load acting on each bolt. How many bolts are present? There are 6 bolts. So here the value of N is equal to 6. Now we can say that the value of torque which is applied is nothing but equal to, by considering action and the effect, okay, this action is resulting in an effect, okay, 6 times P into radius, isn't it? Now from here I need to identify how much is the load which is acting on each bolt. Okay, let's say this is 10 kilonewton meter, 10 into 10 power 6 is equal to 6 into P into 80. From here we'll get the value of P. So P is equal to, okay, let me write this as 10 power 7. So what is 8 6 are? This is 480. Let's keep this as it is. Now as we have got the value of P, now what is he asking? Okay, we know that the load which is acting on the bolt, this should be lesser than or equal to its shear strength. What is the equation for shear strength here? It is SYS, it is, this load should be lesser than or equal to SYS into pi by 4 d square, and here if you are considering factor of safety, the factor of safety comes. Let me substitute these values. Is the value of SYS given? The yield strength of the bolt material is given as 200 megapascal. He didn't specify the shear strength of the material, he specified yield strength. So this becomes equal to 100. SYS value here is 100 divided by N. What is the magnitude of N here? Factor of safety given. Is any factor of safety given in the question? Observe. Connecting two shafts, the shaft transmits a torque, the bolt material is 200, shank diameter is nothing, no factor of safety is specified. So we are considering this value to be 1. This is pi by 4 into d square. Okay, so what is this? 10 power 7 divided by 480. Let's calculate this value. On both the sides, what cancels out? 100, and here this is 10 power 5. Okay, 5 10 power divided by 480 into 4 divided by pi. This is the value of d square. The value of d comes out here as somewhere around 16.3 mm. Okay, somewhere around 16.3 mm is what we are trying to get. Okay, let's see this again. Okay, it is coming out to be 16.3 mm. Now, if I need to round this to the nearest integer, what is the answer that we are going to get? Okay, so is that 16? Can we downsize the member, or can we upgrade, can we increase the size? So generally, I cannot go with downsizing the member. Okay, if at all, if he is asking us to consider the principles of rounding of numbers. Okay, if considering principles of rounding of numbers, so I can say that the nearest integer to this member to be 16. So here the answer could be, considering the principles of rounding of numbers, I can say that the nearest answer could be 16 mm. Okay. If the answer would have got, if that would have been 16.7 or 16.8, the next integer would be, highest one will be considered. But is this the safe one or the unsafe one? As we are downsizing the member, as we are trying to decrease the material, as he is asking us to choose the value to the nearest integer, remember that it is little unsafe. Okay, we require a minimum of 16.3, but here we are trying to use, because of the constraint here, as he says, so round this to the nearest integer. That's the reason why, as we are rounding this to 16 mm, it is little unsafe. Okay, don't worry regarding this. So whatever he is asking for, we need to find the same thing here. Okay, moving to the next one. See this question. This is one of the most important one. A journal bearing having 125 mm diameter, a 125 mm length, and C by R ratio of 0.0004 carries a radial load of 12 kilonewtons. The frictional force of 18 newtons is developed at a speed of 240 rpm. The viscosity of oil, according to Petrov's approach, is, he is asking us to identify the viscosity of oil. So how to find this value? Here he gave the frictional force, okay, and he also said that how much is the radial load which is applied. Now here we know that, okay, so what is the equation according to Petrov? So we know that it is mu is equal to 2 pi square into Z n by P into R by CR. But here, so to identify the value of viscosity, we require at least the value of mu. The value of mu here is unknown. He didn't give the value of mu. Observe. Observe here in the data, the value of mu is not given, but instead of mu, he gave frictional force. So we know that mu is nothing but equal to frictional force divided by normal reaction. So due to applied radial load, we are getting normal reaction, which means 12 into 10 cube is equal to 2 pi square into Z, which we need to identify. N value is 240 divided by 60 divided by, is the value of pressure mentioned? No, the value of pressure is also not given. So I can write this as 12 into 10 cube divided by 0.125 square. I can send this 0.125 square to the top. Why? Because here you can notice that it is a square bearing. So it is 125 mm in diameter, 125 mm in length. That's the reason why L into D value is 0.125 square. So why did we consider that in meter? Why? Because the pressure should be in Newton per meter square. Okay, into R by CR. But here, if you notice, the value of C by R is given as, C by R value is given as 0.0004. So which means C by R value is 0.0004. If you notice on both the sides, 12 into 10 power 3, 12 into 10 power 3 cancels. So 6 ones are, 6 fours are 24. Okay, here we can notice this is 4 ones are for 0.0001 times. Okay, what is 0.0001? Let's do this calculation and find the value of Z. 2 into pi square into 0.125 square divided by the value of Z comes out as 0.026 Pascal second. Okay, this is the value. Why here? So he's asking us to round this to the 3 decimal places. So if you are rounding this to 3 decimal places, we are getting it as 0.026 Pascal second. I guess this is very much clear to you. Okay, now moving ahead, let's see the next equation here. So these are all the numerical answer type questions that are generally expected. If you have conceptual clarity, remember solving these questions is very easy. You should be fundamentally strong. That's the reason why I always suggest or recommend you to concentrate on the fundamentals. If you are good at fundamentals, if your foundation is really good, so you'll be able to solve any complicated problem with ease. Okay, now moving to the other simple questions, let's see them. Which theories are suitable for ductile material? Can you please say me which theories are generally suitable? Okay, we know that this is MSQ. So in MSQ, it is not maximum principal stress theory. So it can be maximum shear stress theory. It is considered to be the safest theory. Okay, as well as it is not maximum strain energy theory. Maximum distortion, it is considered to be the accurate theory. So the answer here for this question is B as well as D. Okay, now moving ahead, let's see the next one. Which among the following are frictional clutches? Okay, observe and say me what is a frictional clutch here. Is single plate clutch a frictional clutch? Yes. Is multi-plate clutch a frictional clutch? Yes. Is positive clutch a frictional clutch? No. And here a cone clutch is a frictional clutch. So the answer here is A, okay, B as well as D. Moving to the next equation. Which of the following statements is true for differential band brake? So read this question, observe this question and say me what is the right answer. So it is neither self-energizing nor non-self-energizing brake. Whether this statement is right or wrong. We know that, so the differential band brake is always self-energizing. The first statement here which is given is completely wrong. Okay, it is a self-energizing brake. True. Self-locking is possible when maximum tension supports braking. We know that in case of differential band brake. Okay, so let me consider this to be the arrangement, as we have this to be the lever. Okay, let's assume this to be the fulcrum. Okay, and we can notice that these are the tensions that we are getting, and let's assume this to be the load which is applied. Okay, this is P. For this case, if you notice, okay, if maximum tension is on, so here in this case, if this is action, this is reaction, this is our support. Why? What is the reason? The applied moment is in counterclockwise direction, the reaction is in clockwise direction, the additional here is also in counterclockwise direction. As this is the additional moment that we are getting, this additional moment or additional tension, so if this is supporting your action, then that will lead to self-locking for sure. Now what is said here, when maximum tension, okay, self-locking is possible when maximum tension supports braking. Yes, this is absolutely true. And here the torque capacity is less when maximum tension supports braking. Remember that when maximum tension is supporting braking, then that system will lead to, there is more support for braking, right? When there is more support for braking, how can we expect less torque capacity? Remember that the torque capacity when maximum tension is supporting braking will be more than minimum tension supporting braking. So which means the option D is wrong. So the answer here is B and C. I guess you are preparing very well, or so, as there is only limited time, almost a month's time. Try to pay more attention to the fundamentals at least now. Okay, so with this, yes, we'll conclude this session here. I wish you all the best for your examination. Take care, everyone. Bye-bye.